Hello, my name is Alok Pratap Birendra Singh, and I'm a student of MSc Advanced Engineering Management, and I'm here to represent my dissertation poster topic, which is an investigation into wind turbines. And my supervisor name is Dr. David Love. Starting with the overview, the modern energy sector is facing challenges from two different crises, including energy insecurity and climate change. In comparison to the traditional fossil fuels like oil and coal, that is responsible for this massive greenhouse gas and increased global warming. The change from polluting energy to clean energy alternatives not only helps support environmental sustainability but also aids in maintaining the net zero carbon targets in each and every nation. Wind energy has emerged as one of the most promising alternatives among all other alternatives. Modern wind turbines include very sleek blades and smart sensors that are quite different from the traditionally made wind turbines. And these wind turbines help harness the natural and unlimited force which is the wind. The aim of this project is to evaluate the potential improvement of electrical efficiency in horizontal axis wind turbines by up to 2% through design modifications and assess the associated environmental and maintenance trade-offs. The objectives are to identify key design parameters that influence the electrical efficiency of horizontal axis wind turbines, in which we find out the design factors which affect the turbine efficiency the most, and to model and simulate proposed design improvements and quantify then impact on electrical efficiency across the different wind speeds, in which we use models and simulations to test design changes under different wind speeds. Then other objectives are to analyze the environmental implications of increased efficiency, including life cycle emissions and material uses, in which we study how higher efficiency impacts the environmental and material use. Then to evaluate the operational trade-offs, including maintenance frequency and cost associated with efficiency focus design changes, and in which we check the trade-offs like the extra costs and the maintenance issues. The other objective is to propose realistic policy or engineering recommendations for implementing such design optimizations in future wind turbine projects, in which we suggest the policy and engineering ideas to apply these improvements in future. Moving to the rationale, renewable energy sources are replacing the fossil fuels as the world's needs for sustainable energy solutions is increasing. The goal of this study is to comprehend the technological, environmental, and socio-economic ramifications for wind turbines. In contrast of coal or natural gas, wind energy produces electricity without emitting greenhouse gases, which makes wind turbines an essential tool for reaching the net zero carbon targets. However, wind turbines have several drawbacks, including the irregular energy output, the high initial costs, environmental and wildlife impacts such as those birds and bats striking to the wind turbine rotor blades, and local communities. Moreover, as technological advances, there is an increasing interest in boosting the grid integration, increasing energy efficiency, and optimizing turbine design. The study has investigated advancements in energy storage integration, offshore wind development, and stronger turbine blades, designs, and AI power predictive maintenance. Literature review. The technological development of wind turbines and the fundamental principles are examined along with comparative views between conventional and contemporary turbine systems. The transformation of wind energy from kinetic to mechanical and finally electrical energy forms is still the fundamental idea behind the operation of wind turbines for both modern and traditional turbines. The wind drives the rotor blades of contemporary horizontal axis wind turbines, which in turn drive the shaft that is connected to the generator through the gearbox. The aerodynamic rotor blades of contemporary wind turbines are composed of those composite materials like this carbon fiber or fiberglass, which greatly increases their durability and efficiency. On the other hand, these modern wind turbines have these yaw mechanisms and active pitch control systems driven by sensors or microprocessors. The wind sector has created more than 1.46 million jobs, providing an opportunity to enhance the employment rate across the world in 2023. These jobs rose from 500K in 2009 to 1.46 million in 2023. As we can see this figure in the conclusion, the growth was fast in 2009 to 2014, then flat from 2015 to 2019, and picked up again after 2020. Overall, we can see the jobs tripled in 15 years. Most existing studies do not fully consider important local issues such as this land use conflicts, then the public opinion, and the long term cost of maintenance. According to the figure in literature review, the study focuses on following areas, which are technological evaluation and working principles, in which examining how wind turbines have evolved over time and understanding the mechanisms behind their operations. The other areas are the energy efficiency and output performance, in which critical evaluation is done to know how effectively and efficiently wind turbines convert wind energy into electricity, and the assessment of their overall performance and reliability. The environmental, economic, and social impacts is the other area, in which analysis is done of the effects of wind turbine installations on the environment and consideration of economic cost benefits and community impacts. Other areas are these challenges and limitations in large scale deployment, identifies the barriers scaling up wind energy, and issues related to management and integration in energy systems. Those future innovations and policy frameworks, which includes exploration of upcoming technologies in wind energy and review of global policies supporting renewable energy deployment and development. Moving to the methodology, the study adopted an interpretivism philosophy by focusing on to the understanding of complicated and context-oriented factors that mostly influence the efficiency of wind turbines. It helps in acknowledging that knowledge is socially constructed and is subject to assumptions. It is well aligned with the thematic evaluation method that is used and which allows deeper information analysis into the technical, operational, and environmental impacts. An inductive approach has been followed in this research study at his has aimed to explore new themes, new patterns, and new insights related to the wind turbine technologies and highlighting its impact without depending on a predetermined theory. The inductive strategy created a more detailed and information rich investigation to build well structured conclusions. This study adopted a qualitative secondary design of the research, which is helpful in critically analyzing how design modifications in horizontal axis wind turbines can improve electrical efficiency. The application of an inductive approach helps this research in evaluating 30 journal articles that are published between 2021 to 2025 through the filtration of the Prisma framework to ensure there is reliability and connection. According to the figure, initially 100 articles were identified and 80 were registered, from which 20 were removed due to duplicate records, then the ineligible automation tools, and other reasons. After moving on to the other process, which is of screening, 25 more articles were removed due to retrieve reports, then the language difficulty and irrelevance, and at last, in the final selection process, 5 more articles were removed due to the misconduct research approach, and 30 articles were finalized. The gathering of this data was usually conducted through Google Scholar, which had applied simple inclusion and exclusion criteria. Then this thematic analysis was chosen to identify the main patterns, including these policy implications and aerodynamics optimizations and environmental trade-offs. Moving to this research outcome and discussion. Under practical operating conditions, research indicated that small design changes can boost horizontal axis wind turbines and electrical efficiency by up to 2%. The research found that the tower height and the hub elevation and generator arrangement affects efficiency the most. Optimized blade aerodynamics and yaw alignment and the wake steering increased efficiency by up to 0.5% to 2.1% in aero servo electro simulations. The study has also found that the efficiency increases the cut lifetime emissions by 0.7% to 1.5% per kilowatt hour and turbine count, reducing the land usage and ecological disturbance. While direct drive systems decrease mechanical stress and enhance the dependability, and they are expensive initially and you need to pay like around a huge amount in the start. The research recommended modular turbine architecture, then innovative blade designs and recyclable materials. And due to longer lifespans, higher energy conversion rates, newer turbines have lower life cycle emissions. The study has also highlighted the feasibility of these solutions by acknowledging the balance between lower fatigue loads and higher control system demands. According to figure, we can say the wind is captured by turbines and converted into rotational motion. Then this motion is transferred through a gearbox into mechanical energy. Then the generator then transforms it into the electrical energy. Then electricity passes through a power interface and is supplied to the grid for consumption, while also posing some ecological concerns such as impacts on birds and surrounding environment. Conclusion: proper modeling and simulation of proposed designs should be improved and quantified for a positive impact on electrical efficiency throughout different wind speeds. The usage of fossil fuel is responsible for higher emissions of nitrous oxide, methane, and carbon dioxide, which are responsible for respiratory illness and environmental acidification. The development of efficiency of horizontal axis wind turbines is not just sufficient, but greater environmental damage can be observed in future. And these carbon fiber blades are responsible for excessive emissions during wind power manufacturing. It can be identified that environmental factors like atmospheric pressures and the surrounding environment are responsible for boosting wind energy production. As we can, as we already discussed this figure before in the literature review, that the jobs are almost tripled within 15 years, and it has given opportunity to 1.46 million peoples. And class the ethical considerations, here the ethical consideration has been undertaken to ensure integrity and responsible utilization of security data, respecting intellectual property rights, and for collecting and using others research work. Data Protection Act of UK has been followed, and all the protocols are followed, maintaining academic honesty throughout the research paper. This enused is the upholding of ethical standards, avoiding biased information.